Welcome! Our objective for this video is to calculate the amounts of our acid or base required to perform our chemical reactions. This is a type of stoichiometry. When we have acids and bases, we can quantify how much of our acids or bases are required to react with each other using a technique known as titration. Titrations are a nice laboratory technique to do some quantitative analysis to figure out exactly how much of something is present. The idea is that we have a known reaction, in this case between an acid and a base, where they are going to neutralize each other. We can try to set up our experiment so that we have exactly the perfect amount of our acid and base present. In other words, carefully combine our chemicals so that neither one is limiting, so that there are the perfect amounts of each. This is known as the equivalent point. Stoichiometric amounts of our acid and base present in the same beaker. In the lab, we're going to start with a known solution and an unknown solution. By known and unknown, we're talking about the concentrations. We should know what those chemicals are, just not how much is dissolved in each of our solution. The plan is to combine those chemicals together in a nice known reaction and stop when we are at that equivalent point, when we have those stoichiometric amounts, when we have exactly the ratio described in our chemical reaction. One way to know that you are at or close to the equivalence point is by using an indicator molecule. This is a molecule that changes its color when you are at that equivalence point. A common example is this phenolphthalein compound, which is colorless in the presence of acids, but turns bright pink in the presence of base. We can call our known solution the titrant, and we can call our unknown solution the analyte. Our plan is to carefully combine the titrant and the analyte together and stop exactly when the color changes and when we have that good stoichiometric amount of those two chemicals. This whole experimental setup is designed so that we can do our regular stoichiometry calculation. Just our same 3 steps that we know and love. Find moles, find the chemical that we care about, and then find the unit that we want. Here's what this looks like schematically. We can start with some acid in our flask down below, and maybe some base in our burette up above. This is a specific example with a specific base and acid, but it could be true for whatever base and whatever acid that you want to combine. We'll put a few drops of our indicator molecule into that flask down below. Since it's in an acid, it's colorless right now. Once everything is set up, we can start to carefully add our base to our acid. And when the solution turns pink, that means our reaction is done. Then we need to stop adding our chemicals and use our burette to measure exactly the amount of our NaOH that has been dispensed. We can measure that volume of our NaOH. If our sodium hydroxide is that titrant, we should know its concentration. And using our stoichiometry technique, we can solve for how much of our acid had to react with that known amount of our base. There's a lot of terminology here, but that's basically it. We're carefully doing a reaction and stopping when we know that we have a good ratio for our chemicals. Then we can do our nice stoichiometry calculations that we already learned how to do. Here's what these problems might look like. If you have sodium hydroxide and you don't know its concentration, but you react it with 12 milliliters of 0.2 molar sulfuric acid, we can figure out the concentration of that NaOH, knowing that we started with 25 milliliters of, not acid here, NaOH. Sorry for that typo. We can start by writing our balanced reaction. Next, we can set up our plan. We know a lot about our sulfuric acid. We can try to figure out how many moles were involved in our reaction. Then we can get to the moles of our sodium hydroxide, and finally get to our concentration of sodium hydroxide. In order to get to moles, we can use this molarity. Molarity is the same as moles divided by liters. Here we have 0.2 moles for every 1 of our liters. I've left one extra blank space here. It looks like we need to do a metric system conversion first so that our units actually line up. Our second step can be to convert to the chemical that we actually want. To switch from one chemical to another, we need to use our balanced chemical equation. In this case, 2 sodium hydroxides are required for every 1 of our sulfuric acids. I'm going to stop and get an intermediate answer here. We have 4.8 times 10 to the negative 3 moles of our sodium hydroxide. This isn't our final answer. We want to do one last step and calculate the molarity. To get the molarity, we need our moles and we need our liters. Well, good news. We just calculated the amount of moles. All we need to do next is calculate the amount of liters. In the problem, it says we have 25 milliliters of NaOH, which we can use our metric system conversion to get over into units of liters. There we go. We can plug our values in here and figure out our NaOH had a concentration of 0.192 before we started to react it with our acid. It's time for you to take a try at this. We have a practice problem here, so grab your pencil and paper, try to calculate a nice answer. Congratulations, now we can calculate the amount of acid or base required to perform our reactions using stoichiometry. This is oftentimes a titration technique. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.